your observables on your lab layout. I'm going to show you something really cool. So make sure you can see what I have up here. Feel free to move around. Jose?
I hear a cow. That was last week's project.
Okay, we ready to watch something really cool?
Yeah.
Okay. Okay. Okay, ready?
Press the button.
Ready? Ready?
Wait, am I observing?
Okay, the event starts now. Did that meet everyone's expectations?
Yeah.
Okay, was that cool? Not really, right? What do we see happen? Whoa. Okay, let's. I hear a lot of good ideas. We're gonna raise our hands to express our well-formed ideas. My question is, what did we see happen, Kate? Okay, what kind of motion is this? Travis. Okay, we see tension, but how can I describe the motion? Unbalanced? Change of velocity. Who thinks change of velocity? Who saw that? What's another way of saying that? It accelerates. Very good. All right, I'm going to do this. Do you think by doing that it'll be a little cooler?
No.
Let's see. Let's do it one more time. Okay, ready? Okay, was that a little cooler?
No.
Louder? So, Kaylin's saying it's faster because of something? Less friction, okay? Anyone else think it went faster? Yeah. That time? Okay.
I think you told it differently.
Was the acceleration the same as the first one?
No.
Let me ask that again. And how many of you think the acceleration was the same this time as the first one? How many of you think it's different? How many of you don't know? Okay, pretty split up. Okay. If you, how am I pulling this? What's this called? Do you remember what it's called?
Oh, it's a spring scale.
Spring scale.
There we go.
Spring scale.
So what I've been doing. What I've been doing is keeping it at about here. Okay. I'm gonna switch it up to be here. Anyone see the difference? No. What's the difference? I'm pulling it lower. Yeah. So is that going to be cooler if I pull it with this much instead of this much?
Yeah, it's going to be a lot cooler. I think it's going to fun.
Okay.
This is a correction step.
You know what though? Yeah, let's just do it real quick. Okay, ready? No one's over there? Okay. I don't know.
You want to look.
Here we go. Okay.
Good thing.
Was that cooler? Yeah. Okay. None of you seem impressed. All right. Let's think about what we can measure. Let's set up a table for our measurables. Okay, will you put this up, please?
Can I go back to my slide?
Okay, back. You guys can sit back down. Anali, Jose, Aaron. Oh my God. Oh, write down what you observed. What do we see happen?
observables.
Take it off me. Go on air with me.
Hey, high five. Look, it's
Finally. This guy's on drugs. Hangover.
Can we do a double high five again? Can we say that again?
Does it feel that you're
Okay, all stars here. All stars. All stars. If I had 4 hands, I'd give you all high five simultaneously.
You just killed an ant.
But I could do 2.
Still alive. I just broke its leg. It's alright. It feels okay.
That's all you broke.
5 seconds. Wrap up your observables. Okay, folks, let's meet back up here. So I'm going to ask you a few questions, and you hear me say it a lot. There are a lot of us in here, and a lot of us have awesome ideas, but I'm going to call on whoever raises their hand to share their ideas. My question being, what can we measure about what we just saw? Okay.
Measure
God,
the
he did the voice
the
thing.
the speed.
The speed?
Yeah. Maybe like the velocity.
Maybe the velocity. Yeah, I like that.
Yeah.
Okay, from someone else, what symbol do we use for velocity?
Yo, the
Travis?
you can use that V.
V, okay.
Raise your hand. My hand's been
Okay, this time I'm gonna ask it from everyone. So just to remind you, I'm gonna go like this when I'm looking for hands. And if I'm not doing that, you can all respond if you know it. What units do we use for velocity? I hear meters per second. That is correct.
Yeah, sure it does.
Okay, this is a big one. How can I measure velocity from what we just saw?
You can. I don't even know.
How can I measure the velocity of the car?
You can do some like measuring stuff.
How did you measure the velocity?
Oh, wait, I might actually
I
know
can't hear
this.
you, Kate. Travis,
the speed and acceleration.
speed and acceleration. What tools am I going to use to measure velocity?
The spring.
Spring, maybe? Dave?
Can we use that thing that we use like with
The thing?
What about the equation?
What do we have there? Look at what Jose's holding up.
The
The thing.
What's that other thing that's in front of you?
is the E tracker thing.
Yeah, that's what I was trying to say.
It's something by Werner.
No, that's what you see the thing. That's what I was trying to say.
The Nokia Edge.
What's this called?
I don't know, but I was trying to say the little touch
It's
thing.
like it's like
Motion
a long
detector.
complicated
Motion
name
detector.
that I don't like to say.
Is it a motion?
Motion sensor.
Motion sensor.
Woo!
That's not the right word.
I guess.
We're going to use a motion sensor. Or we can use a motion sensor. Okay, what else can I measure about this event? What else can I measure? Travis.
Acceleration.
Acceleration. Excellent. I can. I think I can.
You can.
What symbol do we use for acceleration? It's new. Does anyone remember?
Yeah,
What's the symbol? What's the letter we use for acceleration? Everyone. Maybe we don't remember, it's just A. We saw it once in our notes, but it's still new.
Not mine.
Okay? I'm going to jump to the units. What units do I use for acceleration? Meters per second squared. Okay, this is a big one. I want you to think about it before raising hands or thinking about answers, but I want everyone to think about it. Everyone to think about this question. How can I measure acceleration?
You don't.
Okay, I'll take hands now. Josh.
Speedometer.
An accelerometer?
That's it. Sure.
What did you say?
Speedometer.
Speedometer. We could use that. What are some other ideas? Cade.
So, what you probably do, right? You probably use like some equation that we learned, right? I think
Okay.
that there's an equation that we learned.
Okay.
And what you do, right, is you I think you have to use the velocity or something. Find the acceleration.
Okay, maybe we need to use the velocity to find the acceleration. Maybe we did some problems like this on Monday.
You know I'm totally
Maybe.
winging it right now, right?
Initial velocity.
You're looking at an equation, right? There is a way to do that. But I want to just measure it. Like, I just want to... No, let's do it.
Can you use a ruler?
Travis,
Can you use a motion sensor?
how can we use the motion sensor to measure acceleration? What does a motion sensor show us? Velocity, like just velocity?
No.
Doesn't it graph something?
Yeah.
What two things does it graph? What's one of them? Velocity and
Direction. Oh, no, it's that.
position.
There you go.
Yeah? So if I have I can use that to get a velocity time graph, right?
Right.
If I have the velocity time graph, how can I get acceleration?
You don't.
You just look at the graph.
Oh, you see which way it was going. With the
What do you,
slope.
the slope.
The slopey thing.
We're going to use the motion sensor. And then we're going to look at the slope of velocity time graph. We did lots of this practice on Monday. Now we're going to use it in real life to find acceleration. Motion sensor that just says slope of velocity.
What? What?
Okay, think about the cart. There were bricks on it. I'm pulling it. What else can I measure? What else can I measure? Anali. Time? Okay. How can I measure time? Can you tell me, Anali, how can I, what time am I looking at?
Like how long it took for it to cross a certain point.
Okay. And what am I using?
Like a stopwatch.
Okay. Stopwatch. What symbol do we use for time?
Little T.
Delta T. Oh, it's not delta T. I like that.
And what units do I use for time?
Minutes, hours, days.
What else can I measure? Andrea.
You have the spring scale thing and the force.
Oh,
Force.
good job.
Excellent.
As we go to the fudge.
You're next.
I got this next one. Watch.
We can measure the force. What symbol do we use for force?
Is it light or dark?
We use capital F. And how can I measure the force? Andrea mentioned something about a spring.
Spring.
Josh, do you have an
Thank you.
idea?
spring scale.
Okay.
Thank you, Andrea. Stealing my thunder. Yeah.
Spring scale. Okay. And what are our units of force? You guys got it.
I'm dead now.
I didn't ruin you. It's not grams.
Capital N. There you go.
I did. I don't know how you guys. You guys recovered though. You said Newton. Okay. What else can we measure? Hey.
Well, you see, what you can measure is weight.
Weight. Okay. Yes. We can measure the weight. Similar to weight, Kate. What else can we measure that's similar to weight?
That's similar to weight. So it's like another word for weight.
Oh my God.
Not another word for weight, but weight depends on this.
Mass.
Mass.
Thank you, Kate. You should have let him hang out there.
We can also measure mass. What symbol do we use for mass? And how can, actually, I'm going to jump in on this one. Where's my bucket? Oh yeah, there it is.
Right next to this.
Bucket. And focus. Ideally, we would use what's called a balance. And we've used some electronic balances before, and you guys have seen them. Usually they're back there. That would be the ideal tool or piece of equipment to measure mass. However, and unfortunately, the balances that we have are not well suited. They can't measure anything much heavier than one of those bricks. And so since today we'll be working with some pretty heavy objects, what we're going to use is something close enough. This is a spring scale. It's a very large version. And the thing about these spring scales is that they're well adapted for Earth. So we can assume they work well with a gravitational field strength of 10, which is what we discovered, that we use these to find that. So we're going to use that information to find the mass. You're going to dump whatever it is you're trying to measure in here. And here's my tip. Its 0 point is 0.5 kilograms. Can everyone remember that? Its 0 point is 0.5. So if it reads 3 kilograms, what's it actually? And I thought I'd be strong enough to do this like on my own, and so you're gonna receive a document that says go to Miss Minjares to do this. I ended up hurting my back.
I can help you.
So you guys can help me use this. You guys are free to use this. So to measure mass, we are using a spring scale.
What were you measuring?
Lots of bricks. And what are the units of mass?
Newtons.
We're using kilograms.
Oh, right, because
Yes. We are physicists. We use kilograms.
that's awesome.
So I'm really curious, as all of you I'm sure, as to what the relationships are between these. On your lab layout, some of the directions are that you box the dependent variable. I'm going to tell you what the dependent variable is. It's the variable that we're measuring from all of our experiments. And that dependent variable is acceleration. So we're going to draw a box around it. There are 10 groups that will be working throughout the period today, as well as into Friday. We will certainly not finish this lab today, but we will sure as heck get started. Okay? Jose, can you turn around? All of us have acceleration as a dependent variable. 5 groups are going to have force as their independent variable, and 5 groups are going to have mass as their dependent variable. I'm going to show you right now who those groups are. Kate, I'm going to need you to turn that back up.
My stick.
Hey, Andy, you had it.